Hello Internet! Yesterday we made this. This is our grass shader. What we're going to be doing today is trying to improve this. So I want to expand on this. What we're doing right now is using a instance renderer to draw a lot of them. In this scene there's about 3,000 grass objects in this box. I did go into Blender after the end of the video and actually create a model which looks something like this. Can you see that? Yeah. So it ends up looking a little bit like this, which is just based off of that NVIDIA GPU Gems article we were referencing. So we've got this. What I want to do, I don't know if this is going to work. I should say that now because we'll see. But what I want to do is I want to build a point cloud, which is effectively just a list of points in space, and then use a geometry renderer to actually render the grass that way. So we're going to get rid of all of this. We're going to get rid of our mesh and pretty much do everything from scratch. So we're still going to need all of these points, but we're going to store every single point as a vertex in a mesh. And so, yeah, I've never done this before. So I do have some reference material, which I will drop a link to in the description, which you should definitely check out because there's code there. But we're gonna see what happens because I haven't done this. I have no idea how this is gonna go. So let's find out. So the first thing we need is to create a mesh. So I'm going to create a grass, what do we want to call this? We've got our grass point cloud renderer. So I'm going to actually base this a lot off of our grass renderer. We already have that done. So there is no reason for us to redo all of this, especially since this actually works. So I'm just gonna copy and paste pretty much everything. We are going to change one thing. Are we going to change one thing? Yes. So I'm gonna pull out this matrix. So this update probably could happen in the other one. It actually would probably make more sense. I'm gonna do it here. And if you guys want, you can keep this update. I'll probably post this code. Eventually, it'll end up in the visual effects repo. But what we're doing here is I want to store our position. So if our position, or if our last position, sorry, is not equal to this transform.position. So if we've moved, I want to regenerate this. And then we can do this. So all we're going to do is store a last position, which means if we're not moving this, we're not going to be re-rendering, or we're not going to be re-updating any of this. So hopefully that gets things quite a bit faster, because this part right here, the raycasts and all of that, that's what's slowing down what we're doing right now. So this should get us a better representation with instancing. So let's store the vector 3, last position, sure. So that should initially not be equal. It will initialize everything, and then as we move it around, it should do everything. So I'm gonna actually delete 2 of those grass generators. Remember, with instancing, we can have 1,000 per. Doing more than that requires you to actually redo that or add additional ones like I had done. But I'm also going to just drop this grass renderer and pull in a point cloud renderer. We need the mesh like so, and our material. And then we want 1,000 of them. And the size, let's make that like 30 by 30. And I'm starting to wonder where everything went. There it is. Okay. So important to know, since we're now caching all of this, it's not going to move until I update things a bit. So this sort of gets us back to where we were. The advantage of this is if I look at, why are we only getting 13 FPS? What? We were getting 200 before I did this. I have done so. Okay, there we go. Okay, so that doesn't appear to have helped much. We still get about 200 initially, and then as I add more, it drops down pretty significantly, which is actually kind of surprising. I would have expected that to increase it more. This is not by any means proper profiling. I don't really care. That's not the point of this video. This is just updating it for the sake of updating it. And also, we're going to start generating a mesh, so yeah. So, with our mesh, we can up this up to 60,000, which is probably more than you'd ever want, but what the heck. So, what we need instead of this mesh and this material, we want a mesh filter. So a mesh filter just stores your mesh, and we're just going to regenerate everything. My phone is going off. Thought it was something important. It is not. Let's see here. So this is going to be we're going to call it the filter, I guess. We're going to have a separate mesh, so it doesn't make sense to actually store that. I'm going to store the mesh separately from the filter, just so that we can keep it updated. I don't know if that's going to be an advantage, but we'll see. As far as the matrices, we aren't going to need that anymore. Instead, we're going to need 3 lists. So list 1 is going to be a vector 3, and that's going to be a list of the positions, the vertex positions. So positions, I guess. And we'll initialize that. There we go. Let's create another one. So this int is going to be of our indices. This is going to be super simple. Normally, your indices would store like the face values, and you'd have a bunch of things. Since it's a point cloud, we can actually literally just store the index. So there's actually nothing advanced going on here at all. So this will be indices. New int list, and then finally we're going to store a color, and this is going to store the vertex color. So we're just going to draw the position, the indices, and the color, and then each of those, the color is going to be randomized to kind of give it some visual flair, and then we're going to use our raycast to actually figure out where that point would be, and then yeah, hopefully point it somewhere. So colors, new list of colors. So we get a position, indice, and color. Just for consistency's sake, I'm going to actually give these the proper size that we expect them to be. And then for each of this, if our raycast hits anything, we've got our origin, which is going to be the position we want. So we can do positions.add our origin. We can add our indice, which is just I, and then we need a random color. So colors.add a new color. So these are floats, so 0 to 1. So we can do a random range from 0 to 1. We have to make this a float, so 1.0f. If you just do 0 to 1, you'll always get 0. Something to keep in mind. It's kind of a got you with this overloaded function. Just because if you do 0 and 1, it thinks it's a float, or it thinks it's an int. And then the int one isn't actually inclusive, so then everything just fails miserably. I've done that more than once. So let's do that. I'm gonna zoom in just a bit. People are saying it's hard to read. So that's getting annoying. There we go. So this is our colors. This is our indices, and these are our positions. So we need a new mesh made from those. So I'm going to do a mesh equals a new mesh. Mesh.setColors. Let's actually set our vertices to our positions. I suppose I could have named them vertices, but oh well. We're going to set the indices like so. And then we're going to set the colors. So up to this point, we've done all of this stuff before. Did I not do this right? Mesh topology. I don't actually know what this is doing. Hold on. Sorry. Okay. So what it's doing, these indices, you need to actually specify what topology it's made of from. Normally we do like triangles, for example, but we're not actually in this case. We're making a point list. So we're taking these points and putting them on the submesh 0. And apparently it only takes an array. That's annoying. So we can fix that. It'll take a little bit of modifications. So now we have a new int array of our grass number. We need to set this the fun way now. Int I equals I. So that's just basic setter for array. Nothing crazy, but we can't use a list. And converting it would be super slow, so we're not going to do that. This will be way faster. So now that we have all of that, we should have our mesh created. So I should be able to set that to the filter and just assign our mesh there. And so that should, assuming everything is going well, actually draw our mesh. And I can take out this instance draw. We don't need that either. So effectively what we're doing is we're just rendering a mesh, but we're doing it with a very special mesh. So this mesh, you can't render it normally. I don't even think it would look well. Yeah. So let's add a mesh filter and a mesh renderer. And then this way we should get a render of something. Material. We're actually going to need a special shader for this, so I'm not going to do that yet. And everything else should be good. So if I start this, you don't get anything. There's nothing here. And I don't think those points are. Maybe they are? Hold on. Have I already done what I wanted? Yeah, I have. Okay. I was thinking you would have to modify the camera to actually get this to work. But you don't. Apparently it's already doing it. So each of these dots is a per pixel. So this is going to be per screen pixel dot. So we can see these better. I'm going to do a material. Just a glow material. Let's make it. Sure. And then I'm just going to make it glow a bit. So we'll add some emission. Make them red, I guess. Why not? Let's find this again. And then I want to attach. There it is. Okay. So if I assign the material, we have a bloom enabled. So now you can see each of those points. And I can actually turn off our terrain so you can see those a little bit better. And I can actually, let's just get rid of those too. So all of those orange dots, I don't know if you can see those, but there's a bunch of orange dots. Each of those is a point in our mesh. And it should actually mirror pretty closely what you'd get with a normal, what you'd get with your terrain normally. So this should outline the terrain more or less. And there's actually a game, Sonar Sombre, I think is what it's called. It's by the same developers that made Prison Architect made it. But effectively they made a game that is very, it kind of reminds me of this effect. But anyway, what we can do is we should be able to up this to like 40,000. This may not work. It does, cool. So we now have, theoretically, once we get grass rendering, we would have 40,000 grass instances in here. And we're still getting more FPS than we were getting initially. Granted, that doesn't say much here because we're just rendering points, but we're rendering a lot of points. This is approximately 10, 12 times more than we were doing in that demo I was showing. So if we can pull out a geometry renderer and actually make the mesh from this, I think we're going to get some really nice performance, and we can actually, we're effectively offloading everything to the GPU, which is really good at this kind of thing. So your GPU can render a lot, and it's really good at doing like distributed stuff like this. So hopefully we can take advantage of that. So that's the next thing we need to do, is turn this into a geometry renderer. So I don't know if we want to start that now, but what the heck? Do I want to do this? So I imagine this is going to take a while. But why not? Sure, we'll go for it. I'm going to regret this, but that's fine. One sec, I'm going to create this quickly. Grass geometry shader. And I'm actually going to go and pull out a geometry shader we've already done, so we can reference that, because I don't remember everything that we needed for that. And we're going to have to do some special stuff for this that I also don't remember. So, one moment. So, I am enlisting some help from our low poly planet shader from the World of Zero Arcade, which, speaking of, we are going to be picking that up soon, but that's not really particularly relevant here. We are going to actually copy and paste. That seems like a good idea. And I hope this is enough for us to go to work with. So what this is doing is actually 2 passes. Because this is from our double layered geometry shader. We don't need those 2 passes. So I'm going to actually pull those out and just make sure this still compiles, because I have concerns it won't. There we go. I think that should fix it. Yeah. This is wrong. Okay. So, what this is doing is, this is from our low poly shader, which we do not need. But what we do need is this geometry shader. So, what it's doing is it's taking in a triangle, taking in a 3 input triangle, so we get each vertex, and then outputting a separate triangle. We don't want to do that. Instead, what's the best way to do this? For now, I think for this video, let's just do a quad. We will render quads from this. And I'm going to make up all of this because I don't actually know how this works. Keep in mind, my level of knowledge for geometry shaders is about 2 hours of reading online, so this may not work, but that's fine. Well, I'm sure we'll figure it out. So we're going to take an input of this vertex. It's going to come with a normal position, and a few other things. That's everything we should need. With that information, we should be able to solve pretty much anything. I don't know why my camera's not focusing, but it's kind of annoying. Let's see. So we have our vertex 1, or vertex 0. That's going to be the origin point. That's the center of where we need to be. Next, I'm going to do a float 3, v1, and that's going to be in 0.position.xyz plus our input.normal. So we outputted this v2g, or that's what we're getting in, which looks like this. So these are what we have to work with. We have a position, a normal, a UV, and a color. We don't actually need the UV, so you can probably pull that out, but we're going to work with what we have. So I'm going to add a grass height. So we're going to take our point and extrude it up by the normal, which we don't actually specify, so I should do that. But we're going to extrude it up by that normal, and then we're going to have some sort of grass height, which is going to define how far up we want to actually grow that grass, which doesn't exist yet. So let's add that. Fixed 4. That's not right. Let's do a half grass height. Sure. And we're gonna plug that in here. So, whoops. Totally typing everything wrong. Let's do a grass height. And we'll just do a float here. So you can make this as tall as you want. I wouldn't recommend making it too tall, but you do whatever you want to do. I'm not going to stop you. So we'll default that to something reasonable, like 0.25. So that's not really reasonable, but it's pretty all right. So now that we have that, what do we need to do? So we have 2 points, and effectively these 2 points are our point on our ground, and then some point directly above that. Not necessarily directly above it, it's going to be based off of the normal, which, before I forget, let's plug that in. So we're going to need another list of vector 3s, call it our normals, new list of our grass number. So this is going to give us our normal. We can actually get that straight from our physics raycast. So the raycast is actually going to return what we hit. So we can do normals.add our hit dot normal, I believe. And that should return the normal of what we hit. So if you are casting this into the side of a cliff for some reason, you can actually grow grass out of the side of the cliff. And it should all look fine. But we'll see. So all I have to do is plug this in. So set the normals there, and now the normals are passed in. So that should be good. We should be fine. Now I just need to calculate an actual quad, which I'm not entirely sure how I want to do. We're going to do it the easy way, which probably isn't the best way. But that's the way I want to do it. I don't need that anymore. That's the old low poly planet shader. I deleted it or dropped it because it's just going to cause confusion. So we have normal, color, output. The normals are going to be a problem because I don't know how we're going to solve that yet. But I'm going to want a perpendicular angle. So right now we have a vector going up. I want something that goes across it. And that way we can develop our plane or our quad on that intersection between the two. So I'm just going to do this the easy way. Like I said, we'll fix this later, but this will get us at least past this point. So our perpendicular angle, I think I spelled that all kinds of wrong. But we're going to do that, which is just along the x-axis. So we're going to have whatever our y value is, and then along the x-axis in world space. Which, that's not ideal. Ideally, like, the simplest solution would be to have everything face the camera. This is going to make everything kind of flat, so if you look at it at an off angle, everything is not going to line up. But right now we're just doing quads, but we'll actually expand this so that we get that normal 3 quad style. And when we add that, everything should get a little bit nicer. So now if we take our input of our normal and our perpendicular angle, we should be able to actually calculate a face normal, which is going to be the normal value of the grass itself. And the way we do that is we do a cross product of the perpendicular angle. I should have chosen something that was easier to spell. It seems like an easy problem, but actually I'm having a lot of trouble spelling that, and I feel like I'm not spelling it the same. But we'll pretend like it's right. So what a cross product does is if you take 2 vectors, you get a third vector that is the opposite of them. So if you take your right hand and use your 3 fingers and point them, so like this, if you give it any 2 vectors from that, you'll get the third one. So that's what we're doing here. We're giving it the 2 points of our quad, and so we're getting the one that faces out from that, which we can then use here as our face normal. So that should actually make lighting look correct, or relatively correct. It won't look perfect, but that's totally fine. Input.color, we're playing around with that there. Don't need to do much there. I'm just going to straight out use the color that we plug in. So effectively what we're going to get is we are going to get a ton. We're going to get just a sweeping list of quads, and they're going to be random colors, ideally. Whether that actually happens yet, no idea, but that's the goal. So we have this input deposition, and we have a perpendicular angle. So I can take this angle, or V0, sorry, and add some value to it. This may not work now that I'm thinking about it. I may screw up the math here, and we may have to do some stuff, but I think this will work. So V0 is going to be our root, V1 is going to be up in the sky, and then we're going to take our perpendicular angle, and we're going to multiply it by 0.5 and our grass height. So we're assuming we're doing squares here. We could add like a width here. You know what? Sure, let's do that. It'll save us a bunch of weird math, and that way it's just more customizable. So let's do grass width. Oops, there we go. And we'll make this half of the height. No, we won't actually, because that's also confusing. We're gonna keep this scale there, which is a little bit gross, but we'll get over it. So I'm going to just plug in all 4 points, and then we'll debug what's going on afterwards, because it's not going to work initially. The rotation of the vertices is going to be off. So this is going to do our bottom 2. And then I just need to copy this twice and plug in V1 here. And that should get our top 2. And that should output this. So we should get a quad out of that. We don't exceed our max vertex count. And now we are doing our coloring. So I think this works. I think this makes sense. Background color. Do I want to do this? I think I can just pull out the color here. I think that makes sense. So let's see if this even compiles. It seems to. Oh, I lied. Cross is wrong. So it expects 2 float 3s. Apparently I didn't give it that. And an undeclared identifier of v2. So we need to figure out where those are coming from. v2. There you are. So this normal, we're not using it. I'm going to just pull it out. If you're wondering where all this code came from, check out, I did a 3-part series. It's 3 parts right now. It's going to probably expand over time on low poly shaders, where we used a geometry shader to create a low poly shader. So that's where this source code is coming from. So check that out. I'll leave a description or a link in the description. You can check that out, and it's, I don't know, the recording went a little bit funky, but it turned out all right. Let's see here. Did that fix it? Ish? Yes, cool. So we still have our points. Everything's good. So I'm going to plug in. Well, first I'm gonna remove this terrain render just so we get that. And then we need to assign a material here. So I should be able to assign our grass geometry shader, but we don't have a material for that yet. So let me create that. Grass material. My naming is getting admittedly worse as I go on. Did that work? I don't think that did. Low poly shader, sure. Let's fix that name quick. So we want to do a grass geometry shader. And so that should be all we need. I'm going to turn calling off, so we'll get front and back, just like we had previously. Ooh, that looks funky. All right. And then I just need to attach it to our geometry shader. And camera, you need to focus. All right. This can go on here. And we get quads. They're horizontal, but that's fine. Wasn't really looking for too much there. But this is promising, because what this means is we can actually apply that, what's it called, to it. We can actually take what we have here and actually build full grass, as long as we can define it mathematically, so we don't need like any fancy models. As long as we can take a point and actually render a version of our instance here, we can have up to 60,000 of these and do them fairly well. So if I do that and just nudge it up a bit, I can do this, and Unity is still perfectly fine with this. And actually, now that I regenerated everything, you can see it's actually better than it was. It's a little bit hard to see because I probably added too many of these, but we're rendering 40,000 things, which, again, on a GPU, that's nothing. That's very little actual work, but it looks sweet. So before I leave this one here, let's actually just throw a texture on this. Now, because I don't think it'll be too hard to actually texture this. So we actually already have. Are we outputting UVs? We weren't. So if I make this our geometry to our fragment, if I output a UV from that, we're going to need to specify a UV for each of these, but that's actually super easy. So I need to remember how this is. So the bottom left is going to be 0, 0, which is going to be here. So out.uv equals float 2, 0, 0. And this one is going to be 1, 0. And then we're going to do the exact same thing on top. So this will be 1, 1, because now we're working up top with y having, or the v coordinate having 1. And then the second one is 0, 1, which will be in the top left, I think. I think this will work. We'll figure it out really quickly. But now that I have that, I just need to actually load in our color, or load in our model. Not our model, what am I talking about? We have a main texture. There it is. So I just need to take the main texture and actually figure out where we are, which shouldn't be too bad. So we just take the in.uv, and that will take our inputted G2F that we just generated, grab the UV from that, multiply it by the color, which I don't think is a good idea. So we'll drop that. And then we have this, which is currently drawing our random color, which wasn't actually happening. I'm not entirely sure why that is, but doesn't particularly matter. If I then take that and do C, we should get, granted there won't be lighting on this, but we should get grass. So keep in mind, this is not a clipped thing, and lighting's going to be a little bit funky. We're going to have to write our own lighting for this because geometry shaders do not work with surface shaders, but we can do a quick clip on our C.A minus our cutoff, which I think we already plugged in. We did not. So we can actually pull that in from over here. Getting a little bit ahead of myself, but that's fine. We've got a cutoff here, which is just a float. So I just need to pull that in down here. And then we can actually clip on that. So we're taking our alpha, subtracting the cutoff. So if our alpha value is less than the cutoff value, it won't draw that pixel. And now we get grass, a lot of grass. You can actually pretty much see the terrain just with this, which is super cool. It looks a little bit funky from the top because everything's a little bit weird. You're seeing those like certain lines and things appear because we're actually using the normals. So if you actually like zoom in on this, you'll see the grass actually tilts with the hillside, and that's based off of the normal of our raycast that hit it. So each of those normals is actually affecting the grass. But yeah, I think this looks way better than what we had. It needs more work, obviously, but for what it is, it's pretty cool because we can actually change a lot of this. Did I create 2 cutoff values? I think I might have. Oops. Either way, we can make like super thick tall grass, which this is excessively tall. And I think I may have some variables tied to one another, but you get the idea. Even more grass. So the cool thing is we can also animate this, and we can do it all on the GPU. All I have to do is modify that top little point, move it around, and everything should be good, which we will get into that in the next video. So hopefully you guys are enjoying this. I'm certainly having fun. I've never worked with these before, but they're pretty cool. I think we can do a lot with them. So if there's anything you guys want to see, I'd love to hear it. It's how I get my ideas. And if there's any other ideas you have, I'm constantly trying new things and looking for advice. So if there's something that isn't working for you, or there's something you want me to change, let me know, and I'll do my best to fix it. I'm also experimenting with music in the background. I don't know what specifically is going to be in the background for this video yet, but it's something I'm trying out just because it kind of helps fill like some of the dead spaces and stuff. And it also just, I don't know, livens things up a bit. So let me know what you think about that. I'm still experimenting with it, so if you like it or don't like it or want me to change something about it, now's the time to say it, because now's when I'm experimenting. So yeah, that's about it for this video. So I hope you liked it, and I'll see you guys in the next one. So until then, see you, Internet.